Now another important concept that you need to know is how to get the transfer function from a given Bode plot. So sometimes you will know the Bode plot. You can plot the magnitude and phase of a system with respect to frequency, and then from there you would wish to obtain the transfer function. So how would you do that? Okay, the first step is to identify the number of poles or zeros that are present at the origin. Okay, number of poles or zeros at origin. So from where will you get this information? From the initial slope of the magnitude plot. This is obtained from initial slope of magnitude plot. If the initial slope is positive, okay, so that means it is increasing as frequency increases. Okay, then it means that it is a zero at the origin. But how many zeros? It will depend on the magnitude of slope. That means if it is plus 20 dB per decade, then it means there is 1 zero at origin. If it is plus 40 dB per decade, this means that there are 2 zeros, right? So in general you can write 20 n dB per decade. If n zeros are present, then the slope is going to be 20 n dB per decade. Okay. What about if the slope is negative? If it is negative, this means that this was 0 at origin. If the initial slope was negative, then it means that there will be a pole at origin. Okay. So once again, if it is minus 20 dB per decade, it means there is only one pole at origin. If it is minus 40 dB per decade, this means there are two poles at origin. So in general, minus 20 n dB per decade will give you n number of poles. Next is identifying poles or zeros of the form 1 plus j omega t to the power r. That means there is more than one pole or zero. This is a zero of order r. If you write 1 by 1 plus j omega t, this means it is a pole of order r. Okay. So from the given Bode plot, how will you find out these kind of poles and zeros? Once again, this also can be found from magnitude plot. If there is a change in slope of a magnitude of plus 20 r dB per decade, this means that there will be a zero of order r at that frequency whenever there is a change of plus 20 r dB per decade. Okay. If the change is minus 20 r dB per decade, then what will it be? It will be a pole of order r. As simple as that. Okay. And then what about the gain? How will you identify the gain? So this again you will find out from the initial value of the magnitude plot only. This is why magnitude plot is very important. You can find everything from magnitude plot. Okay. Can be found from initial value of magnitude plot. So once again it will depend whether there are poles or zeros at the origin. So that means if there are no poles or zeros, okay, then what will be the initial magnitude? Irrespective of the frequency, the initial magnitude is going to simply depend on k, that is 20 log k. Okay, so that means if the initial magnitude is given to be x, then you equate it to 20 log k. From here you will get the value of k. Okay, but there are poles or zeros, then what is going to happen? If there are n number of poles at origin. So this we are talking about at origin. Okay. Then what will be the initial magnitude? This is going to be 20 log k will anyways be there minus 20n log omega. Okay. So this if the initial magnitude was, once again if it is x, then you equate it to 20 log k minus 20n log omega. So this is the initial frequency, whatever you've taken. You've taken 1 or 0.1 or 0.01, right? So n, and this n anyways you will find from the initial slope, okay, given in step 1. We've already discussed in step 1. So what is the only unknown here? K. Okay. What about the case when this is for n number of poles at origin? What about n number of zeros at origin? Here just the negative sign is going to be replaced by positive. 20 log k plus 20n log omega. Okay. Once again omega is the initial frequency, n you will know from the initial slope, so k you will find out. If you know the initial magnitude, then you can find the k. Another useful information that you will get from the Bode plot is the difference between number of zeros and poles. So this you will get from the phase plot. Can be found from phase plot. In fact, you can get it from the final value. So you can write here can be found from the final value of phase plot. Final value means when omega is equal to infinity, right? So we know that a pole will contribute to an angle of minus 90 degrees at infinite frequency, right? And what about a zero? This will contribute to plus 90 degrees at infinite frequency. So this can be any pole or zero at origin or not origin also. Any pole is going to give you minus 90 degrees at omega is equal to infinity, and if it is a zero, it will give you plus 90 degrees at infinite frequency. Okay. So then what will be the final phase if there are p number of poles and z number of zeros? The final phase is going to be p into minus 90 degrees plus z into 90 degrees. So you are going to get z minus p into 90 degrees. So whatever is the final phase, if you equate to z minus p into 90 degrees, then you are going to get the value of z minus p, which is nothing but the difference between number of poles and zeros. Okay. So this is one information that you can get from the phase plot. In some instances, this will also become necessary.